Hi! So today we are going to be thinking outside the box. We're going to propose a new perspective and approach to mathematics, and we're going to teach flexibility and critical thinking through the challenge that we are going to mainly focus on. So here's the challenge. We need to connect all of these dots with 4 continuous straight lines. As you can see, you have 9 dots arranged in a square. And our hint is to think outside of the box. So let's try a few things. Let's first think about connecting all the outside dots first, like so. So we do have 4 continuous straight lines. However, they don't connect all of the dots. We're missing this one here in the middle. So let's think about, how about horizontal lines? Well, all the dots are connected, however, the lines are not continuous, and there's only 3 of them. What about vertical lines? Again, all the dots are connected, but there's only 3 lines, and they're not continuous. So now, I'm going to show you the solution. And remember, our hint was to think outside of the box. So, did you think outside the box? Did you think to do something like this? All of these dots are connected. There's 4 continuous straight lines. If you start here, that's 1 line, 2, 3, and 4. And all the dots are connected. So, can you see these 2 more dots? We thought about putting a dot here and a dot here, just hypothetical dots, not real. But when you put those there, it helps us to see that there's a way to connect all the dots. You know, these 2, to clarify, these 2 do not need to be connected, but visualizing them there helped us to connect all of the black dots. So now can you see even more dots? We have put dots in here to make this a larger square, bigger than the one that we originally had, which was a 3 by 3. Now we have a 4 by 4, and that's where this one starts. Okay, so here we can see that there's an infinite number of dots, meaning that there can be an infinite number of ways to completing this problem. For example, we can start here, come down this way, come up this way, go down here, over here. That completes it. That connects all of the dots, and we made 4 continuous straight lines. Similarly, I can change the shape and turn it in many different ways to connect all of these dots, just as a few examples. Here's our next challenge. How many different ways can you write the number 1? Here's an example here. This die is showing the 1 face. Here are a few more examples of writing the number 1. You can have a red one like this. You can have an upside down orange one. This is 0 factorial, which is equivalent to 1. Here are a few more. You can write 1 in block letters in English. Here's 1 in Spanish. Here's a 1 like this. The square root of 1 is equal to 1. Here, 1 to the first power is equal to 1. Here's a few more. 3/3, or 3 divided by 3, is also equivalent to 1. This, sine squared theta plus cosine squared theta is equal to 1, is a trigonometric property, which is equivalent to 1, as you can see. Here's some more. This is 1 times 1, and that's equal to 1. Anything times 1 is itself. And here we have pi to the 0th power, and anything to the 0th power is equal to 1. So as you can see, there are an infinite number of ways to write the number 1. So how is this going to help you? How are these courses going to help? Well, if you wish to learn more, if you want to improve your grades, achieve higher scores, or reduce your homework time, then you should continue with our courses. As you learn new material, we urge you to think outside the box like we did in these challenges, and we urge you to try a different approach, something that maybe you didn't think of at first, or something that is, just different than what people would normally think. If you had a negative experience with mathematics, science, or a particular subject in the past, close that chapter and start again. It's always nice to have a fresh start with things that you're struggling with, and that fresh start can give you a new outlook and perspective on the way to do things. Our next challenge, we will teach you some techniques, tricks, and different, maybe unconventional methods that have been proven to work and to help get through math. And so your challenge is to learn, memorize, and put them in action and check for yourself if they work. You can test all of these things. They're going to work. Thinking outside the box is always a good place to start. Thinking about, what's around you instead of what's just right in front of you, like the dots. And if you see that they do work, do us a favor and spread the word. Thanks.